Just wanted to mention that as I'm going through the next couple of sketches as examples from the Adafruit library, I will not be describing every single line out of them. There's quite a few things that are happening, but I'm only going to pick on a few bits and pieces that I think are more important. You should still spend a bit of time on your own going through these examples line by line so you can understand how they work and how you can best use them in your own sketches. To use the Adafruit library, I'll do a little rewiring. Instead of using hardware serial for the module, I'm going to use software serial instead. This way, I'll be able to have hardware serial communication between the Arduino and the computer, and serial communication between the GPS module and the Arduino. And the Arduino will be running a sketch. They'll be doing a few things, including passing the text output from the Adafruit GPS module. So I'm going to remove the serial wires from the Arduino. Okay, so I'm going to be using RX pin number 3 on the Arduino. So RX, which is my orange wire, is going to go to number 3 pin on the Arduino, and transmit TX is the yellow is going to go to number 2 on the Arduino. So now what I have is software serial that will be implemented on ports or pins number 2 and number 3 of the Arduino, and I'm going to leave pins 0 and 1, the hardware serial, for the Arduino to use with its communication to the computer. So I'm going to plug this back onto the cable that is outside the window and then continue. So the GPS with its antenna is again out of the window. About a minute after I plugged it back in, it got a fix. So let's have a look now at a few things that we can do with the Adafruit GPS library that we can't do at least easily with the raw output without doing a lot of parsing ourselves. So here's the Adafruit GPS library page. Usually the first thing that I'd like to do when I look at a new library is its header file. So at gps.h, go inside that, and you'll see that this library works with GPS modules that contain the MTK33X9 chipset. It's a serial chipset. It includes the software serial library. By default, that's the one that we'll be using soon with pins number 2 and number 3, to which the GPS module is connected. You can communicate with the MTK chip using the serial interface and sending of commands to it, like this one here. So, for example, this command will change the update rate that varies from, say, 1 second to 1 update every 10 seconds if you're doing something that doesn't require frequent updates. And in the header file, we have, or the Adafruit people have created definitions like that, easy to remember definitions that we can issue in the setup function to set up the module before we use it. So I'll show you how that's done in a minute. So there's a few different settings that you can change. So the update rate, the communication rate between the module and the whatever host device the module communicates with. So the default is 9,600 boards, and many other things. All right. Now, all you've got to do is to download the zip file the usual way and install it in your Arduino IDE. So let's go to our Adafruit library and pick up the first example sketch. I'll get Echo, it's the simplest one to begin with, so I can explain a couple of things here. So first, we are including the software serial library so that we can use software serial in ports 2 and in pins 2 and 3. And one little modification I want to do here is that I want to switch the 3 to a 2 and the 2 to a 3 to match the way that I have connected the module to the Arduino. So make that a 2 and 3. Just be careful here. I haven't exactly done what the comments are asking here. So I did not connect TX to 3. Instead, I connected RX to 3. And then I connected TX to 2 instead of 3. So just be careful of this point here. In the setup, I'm setting the speeds for the serial monitor and for the communication between the Arduino and the GPS module. And then you can see that there's a series of GPS.send command statements, so send command, and so on. So this is the way that you can configure the chip on the GPS module. So in this example here, I'm saying to the module that I'd like it to enable the minimum recommended minimum sentences, which are GGA. And if you remember back in the anime data documentation, we've got, I'll give you an example. Actually, I'll go up to the top of this document, and you can see that GGA is just the minimal fix information. That's an example of the sentence that we are asking the Adafruit GPS module to send us. So we are enabling that with by sending this command here. And if we have a look at the header file, just copy that and paste it in here, you'll see that what's happening in the background is that the Arduino is sending this text string to the module in order to configure it the way that we want to. So other things that you can do is to change or to configure the update rate. So in this case, we're going to have one update every 1 second, 1 hertz update, and so on. There's many other different types of configuration that you can put through. Now, down the bottom, you notice something interesting. The loop function is empty. So this sketch is not doing anything in the loop. It's all happening via interrupts. So we configure the interrupt by calling use interrupt inside the setup function, and that will call this function here. So we call use interrupt, we pass it through, so we are going to execute this block here. And what's happening here, these two instructions in particular, we've got 2 registers that come into play, the OCR08, and we pass a value to it, so this can receive, I believe, things an 8-bit register. So we pass a number. And then what's happening here is a comparison. TIM-SK0 is a timer interrupt mask register. It continuously counts from 0 up to, I believe it's an 8-bit register. So it continuously counts up. And then with this expression, when we've got a match between the current value of the timer register and the value that we've set in the OCR08 register, then an interrupt request will be triggered. What is happening in here in particular is that we have a particular bit here. It's OCIE08, and this is a enable compare A interrupt. It's a particular bit that you can find in the documentation for the AVR microcontrollers. And by doing this _BV, we are actually enabling this interrupt so that when the current value in the timer register matches the value that we set in the OCR0A register, then an interrupt will be triggered. Now, every time that the interrupt service routine is triggered, then we go and we execute the code inside here. We get a single character read from the GPS. And because we've set GPS echo to true earlier in the sketch, we'll go and output the character in this car variable to the UDR0 register. The UDR0 register is the USART data register. Basically, this is the register that holds the data for the Arduino as it is sent out in its serial interface to go to perhaps a computer or to whatever serial device is connected to it. So there's a lot of low-level code here, a good place to look for all the information about these registers and what all these different timers and interrupt registers mean is to have a look at the is to have a look at the documentation for the AVRs. So here is the documentation. I'll provide a link in the notes for this lecture. So let's say that you'd like to know, for example, what kind of bit this bit here is. So OCR E08. Then you'll see that this bit here is a timer counter 0 output compare match a interrupt enable. So and a bit of information about what it is. So it's a lot of low level information that is probably not a good time to get into now, but for those of you that are curious, this is the source for what all of these registers and bits do. So don't be afraid to have a look at those things. So that's it with the simple echo sketch. Let's have a look at another one. Let's have a look at another one. So back to Adafruit GPS library, and I'll have a look at the parsing sketch as well. So most of the content here is exactly the same. I'm just going to make a change again to the software serial configuration, and the rest is the same. Now in this case here, the sketch is going to do some parsing. So I'll upload it to see what the outcome is and how it works. So, all right, there you go. So I'll stop it here. So what's happening is, again, you can disable that, of course, if you want to. We get an echo from the GPS module, just the raw data, and then the sketch is going to parse the raw data and give us some more presentable, nice information. So we get the time of the fix, that's Greenwich Mean Time, and the date, fix quality. These are the coordinates. These are, again, the coordinates in a format that Google Maps works, and other information like speed and angle and so on. So I could get this information and copy it, and then go to Google Maps and just paste that information in here, and Google will tell me exactly where I am. There you go. That's my location. So quite nice parsing here, I've got to say. Now let's have a look at how the parsing is happening. So, so here we are inside the loop. We grab the output from the GPS module one character at a time, and then we print it out in the console if we want to. So we could turn that into false if we don't want to get the raw data out. So that's happening somewhere up here. So there you go. You can turn that true into false. And once it's done, right here, we look for a new sentence. So we check to see if a whole new sentence has been received. And then we just call parse edit. So we parse the latest sentence that was received by the GPS module. Then to extract the components from the GPS sentence, we just call gps.hour for the hour and minute for the minute and seconds. We can grab other things like the latitude and the longitude and longitude degrees and so on, gps.speed. So you can see it's very simple to extract individual components out of the data that the GPS module is reporting according to our needs, just by calling an attribute of the GPS object. Okay, so that's about it as far as the Adafruit library is concerned. There's a lot of other nice bits and pieces that you can explore yourself. But the last thing I'd like to show you are the features inside the also popular Tiny GPS library. Let's do that next.